Okay, now let's look at an example of how we would use these Riemann sums to approximate the area under the curve. First, we'll start with a left sum. And let's suppose that our interval is bounded above by f of x equals x squared, below by the x-axis, and let's go from 1 to 7 for our interval. In other words, let me draw this out. So we've got a parabola, and we're going from 1 to 7. And what we want to do is we want to approximate the area under this curve. And we're going to start off with a left sum. So here's what we've got to do. The first order of business is to find the delta x. In other words, how wide are these rectangles going to be? Because what we're going to do, and oh, by the way, let's suppose we're going to use 3 rectangles, just for simplicity and to keep it short and just still observe the technique. That's not going to be a very accurate estimate with only 3 rectangles, but it will serve to illustrate the process. So we want to divide this interval, 1 to 7, into 3 equal parts. So what we're going to do is we're going to take 7 minus 1, that's the length of the interval, divide it by 3. So we get 6 over 3, which is 2. So our delta x is 2. In other words, every rectangle is going to be 2 units wide. So let's see if we can draw that out here. So here's what's going to happen. So here's the way we approach this. We start off with 1, we add 2 to it, we get 3. We add 2 to that, we get 5, and we add 2 to that, and we get 7. And that's the interval. We want to go from 1 to 7. And then I will go ahead and just do, a sketch of the parabola, a rough sketch. So we're going to do a left sum. So here's what happens. We come up here, we go to each one of these, and we make our rectangle. See, I go to 5. So there's our 3 rectangles. So now look what I do. I come over here, and then come over here to 7. See, there's our 3. So notice what I did. I just went to the 1. Since it's a left sum, I'm going to go with the left end point and go up until I hit the curve. Then I come over here to the next one, go up until I hit the curve. Come over here to the next one, go up until I hit the curve. And that's the 3 rectangles. Okay? So the left sum goes like this. So we'll do the left sum. The left sum is going to be 2 times f of 1. That's the first rectangle. Plus 2 times f of 3. Plus 2 times f of 5. Now, we only are using 3 rectangles, so that's it. This is 1, 2, 3. Okay, so of course this is going to be 2 times 1 squared plus 2 times 3 squared plus 2 times 5 squared. Since the function is x squared, and we would add that up, and that would be our left sum. Now let's look at the right sum. Okay. So we're going to approach it the same way. We still use the same width. The width is 2. So we start here at 1. Okay. So here's what we got. We got 1. Add 2 to that, 3. Add 2 to that, we got 5. Whoops. Add 2 to that, and we get 7. So we start at 1 and we go up until we get 7. And then I'll go ahead and draw my parabola. But now, since we're doing a right sum, I'm going to come over here to the right number and go up until I hit the graph. Then I go to the next number, go up until I hit the graph. Next number until I go up and hit the graph. And then notice what happens. If I connect these, if I make a rectangle, I've got my 3 rectangles. See? 1, 2, 3. So now here's my right sum. My right sum is going to be 2 times f of, let's see what this first rectangle is. This rectangle right here is not going to be f of 1, it's going to be f of 3. See how it goes up here? So this is f of 3. The next rectangle is 2 times f of 5. And then finally, the last rectangle is 2 times f of 7. So what we have now is this. We have 2 times 3 squared plus 2 times 5 squared plus 2 times 7 squared. And this is my right sum. So we have the left sum and we have the right sum. Now notice the right sum is going to be an overestimate. The left sum, of course, is an underestimate. But the true area is going to be between these. It's bigger than the left sum, less than the right-hand sum.